Welcome back to Mr. Hassan's Maths channel. This is question number 12 from a older paper, October 2018, Core Mathematics C34. Now this would now be under P4. This would now be under the new syllabus P4 for Edexcel International A-Level. And this question here is about parametric equations. It says figure 3 shows a sketch of part of the curve C, which has parametric equations x equals 7t squared minus 5 and y equals t times 9 minus t squared, where t is an element of the rational numbers. Find an equation of the tangent to C at the point where t equals 1. Write your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. So we want to find the equation of the tangent to the curve at the point where t equals 1. So to find the equation of a tangent now, the tangent to a curve is a straight line which touches the curve at the point. Okay, so we've got to find the equation of the straight line in this form here, what we've got to do is we've got to find the coordinates of the point where t equals 1. And we've got to find the gradient of the point where t equals 1, the gradient of this curve at the point where t equals 1. So let's first work out the point where t equals 1. So when t equals 1, to find the x coordinate of that point, replace 1 inside the x part of this equation. A parametric equation is where the x and y coordinates are given in terms of a third parameter, which in this case is t. So we're going to put t equals 1 into the x part of the equation. It gives us 7 times 1 squared minus 5, which is 7 minus 5, which is 2. And when t equals 1, y is going to be 1 times 9 minus 1 squared, which is going to be 8. So the coordinates of the point when t equals 1, we have the point 2, 8. So if we have a little, sketch of that over here, so it's going to be somewhere like over here, maybe 2, 8, somewhere over there. Okay, we can't be sure exactly what these values are. It could be somewhere up here, somewhere down there, I'm not sure. Okay, all right, so that would be where t equals, that's where t equals 1, for example. Okay, we know that it's going to be where x equals 2 and y equals 8. All right, that's a point 2, 8, for example. All right, I'm going to draw now a tangent. I'm not sure if it was on that side or that side, but I'll just draw it anyhow. So the tangent would be a straight line which just touches the curve at that point without passing through it. So we don't need to do all of this drawing stuff. I'm just kind of illustrating it to you. So we're finding the equation of this line here, which is the tangent. This is the tangent to the curve. At this point where t equals 1, where the coordinates are 2, 8. So we need to find the gradient of this tangent. So we need to find the gradient of the curve at that same point where t equals 1. So we need to find what dy dx is, which is the gradient when t equals 1. So we need to find dy dx. Now, we don't have y in terms of x. We have x in terms of t and y in terms of t. So to find dy dx, we have to use what's called the chain rule. Now, dy dx, when we have parametric equations, is going to be equal to dy dt times dt dx. If we multiply those together, you end up with dy dx. So we know that y, let's say y is equal to, if I expand that to make it easy to differentiate, to differentiate, you have t times 9, which is 9t, minus t times t squared, which is t cubed. So dy dt, we can see is going to be 9 minus 3t squared. And we know x is equal to 7t squared minus 5. So dx dt is going to be 14t. So we can say dy dx is going to be dy dt, which is 9 minus 3t squared, multiplied by dx dt, which is 1 over 14t. Okay, so we can say that dy dx, therefore, the expression for the gradient of this function is 9 minus 3t squared over 14t. So we know that when t equals 1, then the gradient of the tangent is going to be given by, when you put t equals 1 into here, is 9 minus 3 times 1 squared over 14 times 1, which is 6 over 14, which is 3 over 7. So now we have the point, which is 2, 8, and we have the gradient of the line, which is 3, 7. So we know the line passes through this point and has this gradient, so we can find its equation using y minus y1 equals m times x minus x1. So we have y minus 8 equals 3 over 7 times x minus 2. Now multiplying both sides by 7 to get rid of the fraction, you end up with 7y minus 56. 7 times 8 equals 3 times x, which is 3x minus 6. Now I want to make, have written in this form here, ax plus by plus c equals 0, where a, b, c are integers. So I've got the integers now, but I want to bring everything on one side. I'll keep the x term positive, so I'll say 3x minus 7y. I've got minus 6 plus 56, which is plus 50 equals 0. So we can say that 3x minus 7y plus 50 equals 0. That is the equation of the tangent to the curve when t equals 1. So there's part A, answer to this question. Now we can see the gradient actually is a positive gradient. So we can deduce from that that the actual value of t equals 1 is somewhere over here actually, because you end up with a line which has a positive gradient. So it's going to have this type of, the gradient is going to be something like this. So t equals 1 is somewhere over here. Okay, that's t equals 1, somewhere over there maybe. Okay, now, yeah, so there's the answer to part A. Now for part B. It says the curve C cuts the x-axis at the points A and B as shown in figure 3. We got to find the x-coordinate of the point A and the x-coordinate of the point B. Okay, so we can see that it cuts the x-axis. Something cuts the x-axis when y equals 0. All right, that's a basic fact. Anywhere on the x-axis, y is equal to 0. So if I replace y equals 0 in the equation t times 9 minus t squared, I replace the y with 0, I can see that I'm going to get two solutions, well, three solutions actually. I have t, either t equals 0 or 9 minus t squared equals 0, which means that t squared equals 9. So t can be either positive or negative 3. Okay, so t equals 0 and t equals plus or minus 3. So now we need to find the x coordinates at those points. So we can see that when t equals 0, x is going to be 7 times 0 squared minus 5, which is going to be, when t equals 0, x is going to be 7 minus 5, which is going to be 2. Okay, that's when t equals 0. All right. And when t equals minus 3, okay, when t equals minus 3, x is going to be 7 times minus 3 squared minus 5, which is going to be 58. That's going to be 7 times 9, which is, sorry, 48. No, not 48. 7 times 9, which is 63 minus 5, sorry, which is 68. That's right. Sorry, 58. Because that's going to give you 7 times 9, which is 63, minus 5, which is 58. Okay, and when t equals positive 3, what you'll notice, we're going to have x equals 7 times 3 squared minus 5, which will give us exactly the same answer. Okay, so when t equals 0, okay, x equals 2. And when t equals so those are the values of t. Okay, t equals 0, t equals plus 3 and minus 3. Those are the values when y equals 0. Okay, when y equals 0, this is what we get. So let's find out what the x values are. So we need to know, we know that the x coordinate is given by, x is 7t squared minus 5. So when t equals 0, you have x equals 7 times 0 squared minus 5, which is minus 5. So that's when t equals 0, x is minus 5. That must be this point here. This is the point where x equals minus 5. Okay, so that's the x coordinate of the point A. So the x coordinate of A is equal to negative 5. And when t equals 3, you have x equals 7 times 3 squared minus 5. That's going to be 7 times 9, which is 63. 63 minus 5, which is 58. So the x coordinate of b is equal to 58. But there's something interesting here. It says t equals minus 3. Let's see if we put t equals minus 3. What we'll notice is we get the same value for x. You have 7 times minus 3 squared minus 5. When you square the minus 3, it's going to give you 9. So you have the same answer, 58. Okay, so we know for sure b is 58. Now, b is obtained when t equals 3 and when t equals minus 3 as well. Okay, and this is when t equals 0. And we worked out when t equals 1, we're somewhere over here. Okay, and t equals 2 will be somewhere over there. Right? And we'll notice here when t equals minus 1, the x value will give us the same value. All right, when t equals minus 1, if we put it back into here, you're going to get the same value for x as going to be 2. If you put minus 1 squared. So when t equals minus 1, we're going to be down here somewhere. And when t equals minus 2, we'll probably be over here. But when t equals 3, we're here. And when t equals minus 3, we're here. It's like we've gone full circle. So with the parametric equation, you know, the t values take you to different points, okay, on the curve. And sometimes you end up with this type of shape. So if you carry on with the positive t values, it'll probably go along this line. T equals 4, t equals 5, t equals 6. But if you go with the negative t values, it'll go on this line here. Okay, so that's how a parametric curve works. And understanding that will hopefully help us to understand the next point or the next part of this question, which is part C. Okay, so it says the region R shown shaded in figure 3 is enclosed by the loop of the curve C. Use integration to find the area of R. Now, there's different ways we could go about this. Now, probably the most difficult way, which will cause us lots of problems, is to use to find the Cartesian form of this equation and then try to integrate between the limits, okay, which is going to be very difficult here. Probably the simplest way of dealing with it is to use parametric integration. So we know we want to find the area under a curve between two limits, x and, you know, let's say x1 and x2. We have to take the equation y and we have to integrate with respect to x. And that will give you the area between the curve and the x-axis. The area between the curve and the x-axis. Okay, here it's going to be a bit weird because it's above and below, but hopefully what we will do next will make you understand. So now what we can do is we can change this. We need to change this to integrate using parametric equations by using the chain rule. So we have y dx dt dt. This gives us exactly the same answers as this. It will give us the same value as long as I use my integrals in terms of t instead of in terms of x. So all of this has to be expressed in terms of t, and then I can find my integral. Okay, so let's first do that. So I need to have the integral. I'm going to keep this as t1 and t2 for now. I'm going to have y, which is, as we can see, t times 9 minus t squared. Okay, then I'm going to have dx dt. Now we know that dx dt, as we worked out before, is 14t. So this is times 14t. And we integrate that with respect to t. So we have to integrate between the limits, which we're going to discuss in a minute. And this is going to be 14 times 9. Okay, 14 times 9, which is 126. So you have 126, that's t squared, minus, and you're going to have 14t to the power of 4. And that's integrated with respect to t. That's 14t times t, that's 14t cubed times minus t squared. So that is y dx dt dt. Now, as we discussed in the previous part of the question, when t equals 0, we're at this point. When t equals 1, we're somewhere over here. When t equals 2, we're somewhere over there. When t equals 3, we're at this point over here. Okay, so if I stop there, what this will do, it will give me the area under the curve, okay, between those values. In fact, if we think about what x1 and x2 are going to be in terms of this, then x1 and x2 are going to be the x values at these 2 points, which we said were, the x value was minus 5 here, and the x value here was 50, 58. Okay, 58. That was the x value there. So what we can do here is we can find the values of t and t1 and t2 between those 2 points. So I know already that this is when t1 is equal to 0, as we worked it out. And this is when t2 is equal to 3 or minus 3. Now, if we take 3, then we're only looking at this part of the curve. Okay, but if we take minus 3, then we're looking at the whole thing. Okay, because it's like you're taking all of those values, even what's below the x-axis. All right, so it's a bit hard to comprehend in terms of what we know about integration with Cartesian integration. But if I now use my limits as between 0 and 3, I will find this area over here. Okay, and then to find the total area, I need to double it because it's completely symmetrical. But if I use my limits between minus 3 and 3, it's like I'm finding the whole of the area enclosed between from minus 3 all the way around to 3. So I'll find all of this area. So both ways will give me the answer here. Okay, so both ways will give me the answer here. So if I take my limits between 0 and 3 and I integrate this, so I have 126t squared minus 14t to the power 4. Is that supposed to be t squared? Yeah, t to the power 4 dt. Then this will give me, if I integrate it, 126, that's going to be 7 over 3, t cubed, minus 14t to the power 5 over 5, and the limits between 3 and 0. Okay, that will give me a half of the area that I want. Okay, so I'm going to put 3 in here. So I have 126 times 3 cubed over 3 minus 14 times 3 to the power 5 over 5. And that will give me the answer, but it will be half my area. Okay, so I have 126 times 3 cubed divided by 3 minus 14 times 3 to the power 5. Okay, and that's going to be all over 5. So that gives me 453.6. 453.6. So the total area we want is double that. Is going to be 2 times 453.6, which will give us 907.2 square units. And we'll notice that if I did the same thing here and I put minus 3, from 3 to minus 3, if I had integrated and if I put my, the integral will be the same. So if I did this, I'll have 126t cubed over 3 minus 14t to the power 5 over 5. If I put 3 and minus 3 as my t limits, what will happen, I'll get the same thing as this, which is 453.6 minus, and you see what happens is, this is going to be the same value as this, but negative, because that will be a minus 3 here, and that will be a minus 3 there, so that will give me a negative, and I'll have, this will also be, something which I'm going to subtract, so it will be negative. So you'll end up with the same thing, because here we're finding the difference between these two. This will be negative, this will be positive. We'll find the difference, but there will be the opposite sign. So that'll be 453.6, and I can show you that that's exactly what's going to happen. If I put, instead of 3, a minus 3 here, okay, and of course it's not going to, the cube is going to not change it to positive because it's going to be still cubed. And if I put minus 3 in here, it's an odd power. So you'll see we're going to get the same thing, which is negative 453.6. So then you see we have to add these two together, which is like doubling that answer. So it will give us the same answer, 907.2 square units. So the reason why we can use this method here as well is because we're finding the area and we're thinking in terms of t now. So we want to find the area between t equals 3 and t equals minus 3. Okay, between minus 3 and 3. We're finding that whole area between the curve, because now we're doing it parametrically. right? So hopefully I know that's the thing, that the concept the student has a bit of difficulty with. He was saying that basically, shouldn't they be, between here and here, have opposite signs, and then it will give you a zero gradient, a zero area. That would be true if it was a Cartesian equation, like we have something where you have a bit that goes above and bit goes below. So the bit below is going to give you negative area, that's going to give you positive area. When we're integrating with respect to x, okay, here we're integrating with respect to t, so it's not quite the same. Okay, so it's like this is integrating with respect to, you can think of this as a t-axis in a way. So we find the area between or under the curve between these 2 points, between t equals -3 and 3. Okay, so that's how we can understand that. So either you can understand it by thinking of it in terms of, just directly changing these limits. Now, as we know, t equals 58 at 2 times when t equals 3, t equals -3. So if we take this between -3 and between 0 and 3, okay, then we'll get this area here. And if we take it between -3 and 3, we'll get the area, which is double that area, because the area between 0 and 3 is only the area for this section of the curve, from there to there. That's the area between the curve and the x-axis between those 2 points. But when t equals -3 to 3, we're including the area between this part and the x-axis as well. So it's including all of this area and all of this area. Now it's with respect to t now, so this positive negative thing doesn't really apply in this case. Okay, I can guess that it would apply if there's some crossover. For example, if you're finding the area between this part, for example, and I think the area, once they cross over each other, that would become a negative area in comparison to that one, something like that. That's maybe how you can understand it. Okay, so it's like when we find the area between two lines, or between two curves. Okay, if I find the area between that point and that point, I subtract those. I can basically subtract these two equations, and that will give me this area. But if I go onto this side over here, where after they overlap, this area would be negative of that, or will be negative compared to that area. If I find the area between, if I subtract these two equations, because the one that was above is now below, so the area here will be negative. So I guess that will apply. So as long as they are before they cross over each other, okay, then that whole area will give you the same sign. Okay, so maybe that's one way of understanding it. Okay, I'm just trying to think of ways to explain this situation to the student who asked this question from my class. So I hope his main problem was part C here, in understanding this point. Hopefully that clears things up a little bit, and you understand exactly what the concept is now. Anyway, other questions from this particular paper, when I answer them, I answer these old papers over, by request. So you can find the other questions from this paper, if I've answered them, in the playlist that will appear in this region over here. Other questions from the topic of parametric equations from P4 of EdXL can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch a video which will link over here telling you how to use my channel to look for or to find what you're looking for. Thank you for watching, and see you soon.